we have this word problem, this application problem. It says the spread of oil leaking from a tanker is in the shape of a circle, and it says if the radius in feet after t hours, represented by this function, if that's the case, it wants you to find the area as a function of t. So what we need to first do is figure out, well, what do we know about area in this case in terms of r? What is the area of a circle?
Pi r squared.
Excellent. Pi r squared. Oh, that's awesome that you guys knew that so well. Right. Pi r squared. Okay, and then they give us this function. The radius is a function of time was given to us, and they said that was what? 200 root t. Okay, so here is the convenience of composite functions, all right? A composite function, you are putting one function into another so that you can kind of like skip the middleman. So I want you guys to visualize this, like actually visualize what's happening. We have this oil leak, right? It started and it's spreading and it's spreading and it's spreading. Well, this equation only gives me the radius. So if I said, oh, after like 6 hours, what is the area of that oil spill circle, right? Well, what you would have to do is you would have to plug 6 into this and get the radius. And then once you get the radius, then you have to come over and you have to plug it into the area formula. And we're like, you know what? Like, we don't want the middleman. If I have the radius, or if I have the time, 6 hours, what is the area? Nobody cares about what the radius is. They want to know how big is this spill, the area of this oil spill. So the way to do that is by doing composite. So we're going to have an area, right? We're going to do a composite of the radius, and by plugging in the radius function into the area, then we are going to essentially get the area as a function of time. So by doing the composite of the area composite radius function, our new function is area in terms of time. So this is A of r of t, so A of r of t, and then the area is pi, and then parentheses squared, and my r of t is going to be what? 200 root t. 200 squared. What's that going to be? 200 squared. 40,000. Root t squared. T, and then we have this pi, so I'm just going to write that as pi t. If you put t pi, that's no biggie. All right, so my new function is the area now in terms of t. So if I said, oh, after 6 hours, what's the radius or the area? You would just plug in 6 here, and then now you have your area of the oil spill. So there is a huge convenience. It's just something that we don't see a lot of, like, because we don't do tons of application problems. But composite functions, in terms of like applications of stuff that you would use in real life, composite functions are actually one of the most common things that you're going to see used out in the real world.